Good morning, all my dear students. Today we are going to start the new topic, that is Euler Cauchy equation. Before starting this topic, we revised all the portion which are completed in previous lectures. So this is Euler Cauchy equation, and before this lecture, we observed the definition of differential equation, then order and degree of differential equation. After that, discuss about what is the definition of linear differential equation with constant coefficient, and the general solution or the complete solution of that given differential equation is complementary function plus particular integral. So students, in previous lecture we discussed about how to find out the complementary function and how to find out the particular integral. So there are some cases of finding complementary function and some cases of finding particular integral. So before starting this Euler-Cauchy equation, we revise all the portion, how to find out the complementary function and how to find out the particular integral. These are some rules of finding complementary function. These are the 4 cases of finding complementary function. So first case is roots real and unequal. Roots are real and unequal. Suppose roots are m1, m2, m3. These 3 roots are different. So how to find out complementary function? Complementary function equals to c1 e to the power first root into x plus c2 e to the power second root into x plus c3 e to the power root into x, and so on. Why so on? Because depending upon the order of that differential equation, we get number of roots, and according to number of roots we have to expand the complementary function. Suppose order of differential equation is 2, we get 2 roots. Suppose order of differential equation is 3, then we get 3 roots. Means according to order of differential equation we get the number of roots, and according to that number of roots we have to find out the complementary function. Here case 2 is roots are real and equal. For example, roots are suppose m1, m1, m1. These roots are equal. So what is your complementary function? Complementary function equal to c1 e to the power first root into x plus c2 e to the power second root into x plus c3 e to the power m1 x, means third root into x. Means case 1 and case 2 both are same, only there is one difference, that is the roots are repeated. So that's why we write here for first root m1, second root m1 is repeated, so we have to write here x. For second root, again third root is repeated, so that's why we write here x square, means c1 e to the power first root into x plus xc2 e to the power second root into x, and third one is again repeated, so here x square is c3 e to the power m1x. Suppose here fourth root is also available, so here we have to write down x cube. This is x square, and in next step we have to write down here x cube. Case 3 is when roots are imaginary, means suppose roots are alpha plus minus I beta. This is the roots are imaginary. So in this case we have to write down complementary function. This is the standard form of complementary function is e to the power alpha x c1 cos beta x plus c2 sine beta x. This is the case when roots are imaginary. Next, case 4 is when roots are imaginary but roots are equal, imaginary and also equal, so complementary function is e to the power alpha x c1 cos beta x plus c2 sin beta x. This is the case for first root, that is m equals to alpha plus minus I beta. This is e to the power alpha x c1 cos beta x plus c2 sin beta x. Here second root is alpha plus minus I beta. This root is repeated. So here write down x e to the power alpha x c3 cos beta x plus c4 sin beta x. Here we have to write down x because these roots are imaginary and these roots are equal also. That's why here we write down x. So in next, these are the some cases of finding particular integral. In previous lecture, we already discussed about how to find out the particular integral in briefly. So this is the summary of cases of finding particular integral. स्टूडेंट्स ये पर्टिकुलर हाउ टू फाइंड आउट द पर्टिकुलर इंटीग्रल ये ब्रीफली हमने प्रीवियस लेक्चर में देख लिया है. So this is the summary of cases of finding particular integral. So general form of particular integral is particular integral equal to 1 upon f of d into q of x. 1 upon f of d means the equation which is given in the form of capital D, and capital D means d dx. So 1 upon f of d into right hand side, and that right hand side is a q of x. Q of x means a function of x. Right hand is available in terms of x. Suppose case 1 is when q of x means right hand side of that differential equation is e to the power ax. So in this case we have to replace d by a. We have to replace d by a. Case 2, when q of x means right hand side of that differential equation is sin ax or cos ax. So in this case we have to replace only d square. I'm talking about only d square by minus of a square. We have to write down this minus sign outside the bracket and here a square. Suppose right hand side is sin 2x, so you have to replace d square by minus of a is supposed to be 2, so this is minus of 2 square. 2 square is 4 and this minus is outside, so you have to write down here minus 4. Then third case is when q of x means right hand side of that differential equation is x raised to power m, then we have to convert this denominator in the form of 1 plus x or 1 minus x inverse by taking lowest degree term common. जो भी denominator यहाँ पे available रहेगा, in that denominator we have to take lowest degree term common and convert this term in terms of 1 plus x or 1 minus x, and we have to shift this term in numerator. That will be 1 minus x inverse or 1 plus x inverse, and then apply the binomial expansion. Case 4 is when right hand side, that is q of x, is e to the power ax into v, and v is here sin ax, ax or x raised to power m, means this term will be e to the power ax into sin ax, e to the power ax into cos ax, e to the power ax into x raised to power m. So in this case we have to write down this e to the power ax outside, and in denominator we have to replace this d by d plus a, and that a is power of that exponential term. This is d is replaced by d plus a, and according to v, your v is suppose sin x, cos x, or x raised to power m. So according to v, you have to apply the case number 2 and case number 3. All these are the cases of finding particular integral, and we already discussed about how to find out the complementary function and how to find out the particular integral. Next, this is the linear differential equation with variable coefficient. Linear differential equation with variable coefficient. What is mean by the variable coefficient? See, in this equation, the general form of that differential equation is d to the power n y upon dx to the power n, a1 x raised to power n minus 1 d to the power n minus 1 y upon dx to the power n minus 1, and here d to the power n minus 2 y upon dx to the power n minus 2, and so on, and this is equals to q of x. Here a1, a2 up to an, all these terms are constant, and here right hand side q of x is a function of x. It means your right hand side is always in terms of x. So above equation we called it as linear differential equation with variable coefficient. Why we called it as variable coefficient? Because here x raised to power n is a coefficient, x raised to power n minus 1 is also a coefficient, and x raised to power n minus 2 is also a coefficient, and that's why we call this equation as variable coefficient. And x raised to power n, x raised to power n minus 1, x raised to power n minus 2, these are the variable, and this equation is called as the linear differential equation with variable coefficient. And also this equation is called as the Cauchy Euler equation. So it is not possible to solve such type of equation directly by finding complementary function and particular integral. So we have to reduce above linear differential equation with variable coefficient into linear differential equation with constant coefficient. Means we have to remove this x raised to power n, means we have to remove this variable, we have to remove this variable, and after removing this variable, then the given equation is called as the linear differential equation with constant coefficient. And suppose that equation is reduced into linear differential equation with constant coefficient, then we have to find out the complete solution of that differential equation, and the complete solution is complementary function and particular integral. So how to reduce that linear differential equation with variable coefficient into linear differential with constant coefficient? By using substitution x equal to e to the power z, means we have to substitute in place of x e to the power z, and z is equals to, we have to shift this exponential term in other side, that will be z equal to log of x. Next, again we put xd equal to d1, meaning of d is d dx, meaning of d is d dx, and here d1 is also a derivative, d is a derivative and d1 is also a derivative, but there is a slight difference. D means d dx and d1 means d dz. Why we use d dz? Because we have to convert the given differential equation with constant variable into linear differential equation with constant coefficient. हमने substitution use किया e to the power z. So x is replaced by z. So d dx is also replaced by d dz. So that's why we have to write down here x into d as d1, x square d square equal to d1 minus 1, x cube d cube means there is having three terms, d1 reduce 1 we get d1 minus 1, reduce 1 we get d1 minus 2. So with the help of all these substitution, we have to reduce linear differential equation with variable coefficient into linear differential equation with constant coefficient. So we see examples on Euler-Cauchy equation. So this is the example on Euler-Cauchy equation. How to identify your equation is Euler-Cauchy equation. See here in this question, with this derivative coefficient, variable coefficient is available here, and power of that variable and power of that derivative is same. In second term, x is a variable and power of x and derivative, power of that derivative is same. So this is called the Cauchy homogeneous equation. So we have to reduce this equation into linear differential equation with constant coefficient. मतलब आपको with the help of substitution, with the help of substitution, ये जो आपके पास एक्स स्क्वायर है इसको यहां से हटाना है, एक्स जो है इसको भी यहां से हटाना है क्योंकि कोएफिशिएंट आपका वेरिएबल है. सो बाय यूजिंग सब्स्टिट्यूशन x इक्वल टू e टू द पावर z एंड z इज इक्वल्स टू log x, विद द हेल्प ऑफ दैट सब्स्टिट्यूशन आपको ये वेरिएबल कोएफिशिएंट जो है यहां से आपको रिड्यूस करना है. सो पुट x equal to e to the power z. So what is z? Z equal to, shift this e in left hand side, so that will be z equal to log x. So z is equals to log x. Then here xd. So xd equal to d1, because x is replaced by z. So d dx replaced by d dz. So that's why we use substitution xd equal to d1. Then x square d square. So x square d square equal to d1 minus 1. X square d square equals to d1 minus 1. So we have to substitute all these terms in above differential equation. So this x square d square is d1 into d1 square, minus d1 into 1 d1, minus xd equal to d1. So write down here d1 plus 1 y equal to, see here, log x square upon x square, log x square upon x square. So log x is z. So here write down z square upon x square. X is e to the power z. What is the value of x here? X is e to the power z. So x is equal to e to the power z. So what is x square? Here x square is e to the power 2z. So here write down e to the power 2z. We have to shift this e to the power z to z in numerator. That will be e to the power minus 2z square minus d1, that is minus 2d1. So this equation can be written as, here d1 square minus can be written as, here d1 square minus 2d1 plus 1 y equal to z square e to the power minus 2z. So right hand side is z square into e to the power minus 2z. According to previous cases of finding particular integral, we have to apply here case number 4, when right hand side is e to the power ax into v. So how to find out the complementary function and particular integral of this given differential equation? So before finding complementary function, first we have to find out the auxiliary equation. How to find out the auxiliary equation? By considering this equation in terms of d equal to 0. So d1 square minus 2d1 plus 1 equal to 0, and you have to replace this d1 by m. So your equation can be written as m square minus 2m plus 1 equal to 0, and the roots of that differential equation, roots of this equation is 1 1. How to get roots 1 1? We have to split this middle term minus 2m as -1 and multiplication of these two terms will be 1. So m minus 1, m minus 1, so m equal to 1 1. Here roots are repeated, so your complementary function is c1 e to the power first root, that is 1 into z. Why we use z? Because in place of x we use substitution e to the power z, so you have to write down your complementary function in terms of z. So c1 e to the power z plus root is repeated, so write down z c2 e to the power z. Next, here find out particular integral. The standard form of particular integral is 1 upon equation in terms of d into right hand side. Then how to apply this case? So here write down this e to the power minus 2z here outside and replace d1 by d1 प्लस ए कौन सा, ई का जो पावर है, दिस इज ए. सो वी हैव टू राइट डाउन हियर, see here, write down e to the power minus 2z outside and replace d1 by d1 plus a is minus 2, so write down here d1 minus 2 square minus 2, d1 is replaced by d1 plus a is minus 2, so d1 minus 2 plus 1 into right hand side, that is z square. So first of all, we have to simplify this denominator. So here we have to apply the formula a minus b whole square. So a minus b whole square, a square minus twice ab plus b square. So we have to simplify this denominator, that is a square means d1 square minus twice ab means 4d1 plus b square means 4 minus 2d1 minus 2 into minus 2 plus 4 plus 1 into z square. So here next minus 4d1 minus 2d1, that is minus 6d1, 4 plus 4 8, 8 plus 1 9. So next term will be e to the power minus 2z d1 square minus 6d1 plus 9. Then here fourth case is converted into third case, that is x raised to power m. In place of x, here is variable z to the power m. So how to apply this case? This is case number 3. In this case, we have to take lowest degree term. Which one is the lowest degree term in denominator? 9 is the lowest degree term. So we have to take this lowest degree term common. In next step, we have to write down e to the 9 as a lowest degree term, and we have to write down here in place of 9 1 plus, and write down this is as whole term, so d1 square minus 6d1 upon 9. This is 1 plus x in the form of 1 plus x. So we have to shift this term in numerator, that will be 1 plus x inverse. So here next step, e to the power minus 2z upon 9, 1 plus this term is supposed to be, whole term is supposed to be x. So this is 1 plus x inverse. So here we have to apply the binomial expansion, that is 1 plus this term is x. So this is 1 plus x inverse. So formula of 1 plus x inverse, we already discussed about binomial expansion also. So here write down e to the power minus 2z upon 9 as it is. And this is 1 minus 1 plus x inverse. Formula of 1 plus x inverse is 1 minus x plus x square and so on. 1 minus x plus x square and so on. This is the binomial expansion. By mistake here is minus 1. यहाँ पे minus 1 नहीं चाहिए. By mistake minus 1 आ गया है. So this is 1 plus x inverse means 1 minus x plus x square and so on. And right hand side is z square. So here power of z is 2, means we have to take the derivative of z square 2 times. सिर्फ 2 बार ले सकते हैं आप z square का derivative. If we consider the third derivative of z square, it will be 0. So in this expansion, d1 square means double derivative and d1 means a single derivative. So z square का डबल डेरिवेटिव हो सकता है. दैट्स व्हाई वी टेक d1 and d1 square and neglect the remaining terms because derivative of z square will take 2 times. इसलिए d1 और d1 square लेंगे and we have to neglect the remaining terms. ठीक है. Then here 6d1 consider करेंगे, d1 square consider करेंगे, but this is a minus b whole square. इसका अगर हम स्क्वायर करते हैं तो a माइनस बी होल स्क्वायर का फॉर्मूला लगेगा. तो दिस इज a स्क्वायर माइनस ट्वाइस ए बी प्लस बी स्क्वायर. सो 6d1 स्क्वायर, तो ये होगा 36d1 स्क्वायर. सो d1 स्क्वायर मींस डबल डेरिवेटिव. So it is possible to take the derivative of z square 2 times. So from this term we have to consider only 36d1 square upon 81 and neglect the remaining terms. So in next slide, see here, e to the power minus 2z upon 9, 1 minus d1 square upon 9 minus minus plus 6d1 upon 9 plus from this expansion we have to consider only last term, that is 36 upon 81 d1 square z square. Yes, then we have to multiply by z square to the whole bracket. We have to multiply by z whole bracket. So this will be e to the power minus 2z upon 9, 1 minus d1 square upon 9 plus 6d1 upon 9 plus 36d1 square upon 81 into z square. So here e to the power minus 2z upon 9, 1 minus 1 by 9 plus 36 by 81 d1 square, we get 1 by 3 d1 square plus 6d1 upon 9 into z square. Then we have to multiply by z square to the whole bracket. This will be e to the power minus 2z upon 9, 1 into z square is z square plus d1 square upon 3 into z square plus 6d1 upon 9 into z square. Then z square as it is. Next term is d1 square. What is the meaning of d1 square? Double derivative of z square. This is double derivative of z square. So what is the double derivative of z square? Single derivative is 2z.
and then next derivative is 2. So what is the double derivative? That is 2 by 3 plus 12 d1 z square. Meaning of d1 z square is derivative of z square. So single derivative is 2z. So here we write down 2z, and 2z into 6 is 12z upon 9. So your particular integral is e to the power minus 2z into z square plus 2 by 3 plus 12 by 9z. This is the particular integral. Then here we take LCM of this denominator. Here LCM is 3. So here 9 into 3 is 27. So here 3z square plus 2 plus 4z. This is the particular integral of this differential equation. And what is the complete solution of the differential equation? Complete solution is complementary function plus particular integral. So here we have to write down c1 e to the power z plus zc2 e to the power z plus e to the power minus 2z upon 27, 3z square plus 2 plus 4z. This is your complete solution. But when we started solution of that given differential equation, we used substitution x equal to e to the power z. Why we use substitution x equals to e to the power z? For making your differential equation with constant coefficient into differential equation with, sorry, the differential equation with variable coefficient into differential equation with constant coefficient. इसलिए हमने substitution use किया था x equal to e to the power z. So अब हमको क्या करना है? Again we have to replace this e to the power z. So your solution is, we use substitution x equal to e to the power z. ये substitution हमने use किया था for making your equation solvable. So again we have to replace this by log x and x by e to the power z. Yes. So what is the required solution? C1 e to the power z is x. So here C1 x plus z is log x. C2 e to the power z is x. So C2x plus e to the power minus 2z. Here x is equal to e to the power z. So here e to the power minus 2z. So if we write here minus 2, so here again we write minus 2. So what is e to the power minus 2z? This is x raised to power minus 2 upon 27. 3 and z is equals to log x. So this is log x square plus 2 plus 4. Z is log x, so 4 log x, and this is the complete solution of given differential equation. The next example of finding solution. In this example, only your question is find particular integral. Complete solution is complementary function plus particular integral, but your question is only to find out the particular integral. So हम इसमें सिर्फ particular integral निकालेंगे. First of all, we check your given differential equation is in the proper form or not. Here coefficient is 1 by x, but in first term coefficient is not available. So we have to multiply this equation by x square. So here multiply by x square. So this equation is x square d square y by dx square plus multiply by x square, x getting cancel. So x into dy by dx equal to 12 log x up into x square. So x square getting cancel. So your answer is only 12 log x. Again, this is Cauchy, Euler-Cauchy equation. So we have to remove this coefficient, variable coefficient, and make this as constant coefficient by using substitution x equal to e to the power z. So z equal to log x, then x d equal to d1, x square d square is d1 minus 1. This equation can be written as d dx is capital D. D dx is capital D. So this equation can be written as in terms of D, that is x square into D square plus x into D, and here y taking common equal to 12 log x. So we have to use all these substitution in this differential equation. So x square d square is d1, d1 into d1, d1 square minus d1. So we have to write down here x square d square as d1 square minus d1 plus x into d is d1. So here d1 getting cancelled. What is the remaining term here? Remaining term is d1 square y equal to 12z. Log x is z. So we have to find out here particular integral. Particular integral is equals to 1 upon d1 square into right hand side, and right hand side is 12z. So here right hand side is z. So this is case number 3, that is x raised to power m, but d1 square is present here. So d1 means derivative with respect to z, and 1 upon d1 means integration with respect to z. So here term is 1 upon d1 square, and d1 square means 1 double, and 1 upon d1 square means double integration. So write down here in next step, this is equal to double integration of 12z. So here 12z and double integration dz. What is the integration of 12z? 12 is constant. Single integration of z is z square by 2. Z square by 2. And integration of z square is z cube upon 3. So 2 6 are 12, and integration of z square is z cube upon 3. So this will be 2z cube, and this is the particular integral of your differential equation. But we use substitution, z is equals to log x. So we have to replace this z by log x. So this is z log x cube, and this is the particular integral of given differential equation. See another example. Find the particular integral of, only particular integral, particular integral of this given differential equation. Again, this differential equation is Cauchy, Euler-Cauchy differential equation. Why? Because variable x square is here and variable x is here. So we have to convert this equation into linear differential equation with constant coefficient by using some substitution. So first of all, we write down this equation in terms of d. So d dx is capital D. So capital D square plus 4x d dx is capital D plus 2. Y taking common, and this is equals to x log x. This is Euler-Cauchy differential equation. So we have to reduce this equation into linear differential equation with constant coefficient by using substitution x equal to e to the power z. Z is equals to log x, and xd equal to d1, x square d square equal to d1 d1 minus 1. So this equation can be written as x square d square is d1 square minus d1 plus 4 xd is d1. So d1 plus 2 y as it is equal to here x is z, x is e to the power z, and log x is z. So according to your right hand side, this is case number 4, that is e to the power ax into x raised to power m. d1 square, 4d1 minus d1 is 3d1 plus 2y equal to z e to the power z. So particular integral is 1 upon d1 square plus 3d1 plus 2. In this case, we have to write down e to the power z outside, e to the power z outside, and replace d1 by d1 plus a matlab e ka power. So here write down e to the power z outside and replace d1 by d1 plus a, and a means a power of a exponential term. So here power of exponential term is 1. So replace d1 by d1 plus 1 square plus 3. d1 is replaced by d1 plus 1 plus 2 into right hand side is z. We have to expand this denominator, that is d1 square plus 2d1 plus 1 plus 3 into d1, 3d1 plus 3 into 1, 3 plus 2 into z. We have to simplify this denominator. This will be d1 square, 2d1 plus 3d1, 5d1 plus 3 plus 2, 5, 5 plus 1 is 6. So this case is case number 3, that is right hand side is x raised to power m. So how to simplify? Here taking lowest degree term. Which one is the lowest degree term? Your lowest degree term is 6. So you have to take lowest degree term as common. So in next step, we have to take this lowest degree term common, and this one is 1 plus. And we have to consider this whole term as a single term. So this term d1 square plus 5d1 divided by 6. This is 1 plus whole term is x. So 1 plus x. Shift this term in numerator, that will be 1 plus x inverse. So in next step, e to the power z upon 6, 1 plus x inverse into z. And you know the binomial expansion, that is 1 plus x inverse is 1 minus x plus x square minus x cube and so on. So here write down e to the power z upon 6, 1 minus x plus x square and so on. And I already told you power of z is 1 here. So we have to take derivative of z only single time. So d1 means single derivative, d1 square means double derivative. But in this example, power of z is 1. So we have to take derivative of z ओनली वन टाइम. सो यहाँ पे हमारे बाइनोमियल एक्सपांशन में सिर्फ हम d1 कंसीडर करेंगे. d1 मीन्स अ सिंगल डेरिवेटिव एंड इफ वी टेक d1 स्क्वायर मीन्स डबल डेरिवेटिव ऑफ दैट टर्म विल बी 0. So we have to neglect all the terms, only we have to consider phi d1 means a single derivative of z and neglecting remaining terms. So in next, e to the power z upon 6, 1 minus phi d1 upon 6 into z. Then multiply by z, e to the power z upon 6, 1 into z minus phi d1 upon 6 into z. d1 means a single derivative. d1 means a single derivative. So derivative of z is 1. So your answer is particular integral equal to e to the power z upon 6 z minus 5 by 6, and d1 z means a derivative of z, that is 1. So your particular integral is e to the power z upon 6 z minus 5 by 6. But this is not your final answer, because we use substitution x equal to e to the power z. So you have to replace this e to the power z as x, and again we use substitution z equal to log of x. So we have to replace this z by log of x. So next term is x by 6 z equal to log x minus 5 by 6, and this is the particular integral of your given differential equation. Yes. Again we take another example of finding particular integral. This is your given differential equation. Again, this is Euler-Cauchy differential equation. Why? Because variable x square is available here and variable x is available here. So we have to reduce this equation with variable coefficient into linear differential equation with constant coefficient by using substitution x equal to e to the power z. So z equal to log x and xd equal to d1. X square d square is d1 into d1 minus 1. So we have to substitute all these terms. So this equation can be written as here d1 square minus d1 minus d1 plus 1 y equal to sine z. So here minus d1 is minus 2d1 plus 1 y equal to right hand side is sine and log x is z. So we have to write here sine z. So your differential equation is d1 square minus 2d1 plus 1 y equal to sine z. So according to right hand side, we have to apply case number 2, that is right hand side is sine ax or cos ax. So here find out particular integral. This is particular integral equal to 1 upon d1 square minus 2d1 plus 1 into sine z. So in this case, we have to replace square, only square. So replace d1 square by minus of, write down this minus sign outside, a is 1 here. So minus of 1 square is 1. So here is minus 1. So you have to replace d1 square by minus 1. So this equation can be written as d1 square is minus 1 minus 2d1 plus 1. Here plus 1 minus 1 getting cancelled. Remaining term is 1 upon minus 2d1 into sine z. What is the meaning of 1 upon d1 here? What is the meaning of 1 upon d1? 1 upon d1 means a integration and d1 means a derivative and 1 upon d1 means integration. So here write down 1 upon minus 2. 1 upon d1 means integration sine z into dz. What is the integration of sine z? It is minus cos z. So 1 by minus 2 into minus cos z, minus minus here plus 1 by 2 cos of, again we have to replace this z as log x. So this is 1 by 2 cos of log x. So this is the particular integral. Again I take another example of finding particular integral. So here write down This is x square d square minus xd plus 1. This is again Cauchy-Euler equation. So we have to make this Cauchy-Euler equation into linear differential equation with constant coefficient, and then find out the complete solution or a particular integral of given differential equation. So we have to use substitution. X equal to e to the power z. Z equal to log x, and xd equal to d1. X square d square is d1, d1 minus 1. We have to use all these substitution in your given differential equation. So this will be d1 into d1 square minus d1 into 1 is d1 minus xd is d1 plus 1 y equal to log x is z plus this pi as it is. Then we have to simplify this. D1 square minus d1 minus 2d1 plus 1 y equal to z plus pi. So according to right hand side, we observe that this is case number 3, that is right hand side is x raised to power m. Only in place of x, variable is z here. So we have to write down the particular integral equal to 1 upon f of d1. So d1 square minus 2d1 plus 1 into right hand side. This is z plus pi. So in this case, this is case number 3. In this case, we have to take the lowest degree term as common. Which one is the lowest degree term? 1. 1 is the lowest degree term. So taking 1 common, so this equation can be written as 1 plus whole term is supposed to be x. So d1 square minus 2d1 upon 1, this term as it is d1 square minus 2d1. This is 1 plus x. We have to shift this term in will be 1 plus whole term is supposed to be x. So 1 plus x inverse. What is the expansion of 1 plus x inverse? That is 1 minus x plus x square and so on. But power of z is 1, means we have to take the derivative of z only one time, means we have to consider only d1 from this expansion. So we have to consider only d1 and neglect the remaining terms. So this equation is 1 minus d1 square we have to neglect here because double derivative of z is 0. So we have to neglect this term, minus minus here plus d2d1 into z plus pi. Multiply by z plus pi to the whole bracket. So this will be 1 into z plus pi, here z plus pi plus 2d1 into z plus pi. Z plus pi plus d1 stands for a single derivative. So what is the derivative of z with respect to z is 1. Derivative of pi is 0. So we have to write down z plus pi plus here 2. Derivative of z is 1. Z plus pi plus 2. This is your particular integral. But we use substitution, z is equals to log x. So we have to replace this z by log x. So pi equal to, here pi equal to log x plus pi plus 2. This is the particular integral of given differential equation. Then we see last example of this form. This is the last example of finding particular integral. This is your Cauchy-Euler equation. Again, why this is Cauchy-Euler equation? Because here coefficient is x square, coefficient is x. So this represent d. So here write down x square d dx is capital D square minus 3x, d dx is capital D plus 5, y equal to right hand side as it is. So we have to reduce this differential equation into a linear differential equation with constant coefficient. So that's why we use here substitution x equal to e to the power z, z equal to log x, xd equal to d1, x square d square is d1 into d1 minus 1. So we have to use all these substitution in your differential equation. This equation can be written as x square d square means d1 square minus d1. So d1 square minus d1 minus 3 xd is d1 plus 5y equal to, here x is equal to e to the power z. We use substitution x equal to e to the power z. So what is your x square? X square is e to the power 2z. So we have to write here in place of x square, here is e to the power 2z, and sine log x is z. So according to right hand side, this is case number 4, means e to the power ax into v. So d1 square minus 4d1 plus 5y equal to e to the power 2z into sine z. Then we have to find out the particular integral. Particular integral is 1 upon d1 square minus 4d1 plus 5. This is case number 4. In this case, we have to write down e to the power z. We have to write down e to the power z, 2z outside, and replace d1 by d1 plus a. A matlab power of this exponential term. So here, write down e to the power z, 2z outside, replace d1 by d1 plus a. A means 2 minus 4. d1 is replaced by d1 plus a plus 5 into sine z. Then we have to simplify this denominator by applying formula a plus b whole square. So that will be a square plus twice ab plus b square means 4 minus 4d1 minus 8 plus 5 into sine z. Here minus 4d1 plus 4d1 getting cancelled. 4 minus 8 is here minus 4 plus 5 is 1. E to the power 2z, 1 upon d1 square plus 1. Then this case is case number 2. So in this case, we have to replace d square by minus of a square. And what is the value of a here? A equal to 1. So we have to replace d1 square by minus of a square. And what is the value of a here? A is 1. So here 1 square, and this is equals to minus 1. So here e to the power 2z, d1 square is minus 1. So minus 1 plus 1 is equals to 0 into sine z. See here, denominator is 0, means your answer 1 upon 0 means infinity. It means your answer does not exist. So for making your answer exist, if case is failed, so you have to multiply and z e to the power 2z into 1 by 2, and here 1 upon d1 means integration. So integration of sine z and integration of that sine is minus cos z. So your answer is z e to the power 2z 1 by 2 minus cos z. But this is not your complete answer because we use substitution x equal to e to the power z. So here we have to use the substitution, that is here x equal to e to the power z and z equal to log x. These are the substitution. So again we have to replace this z by log x e to the power 2z. E to the power 2z means here x square. So this is x square 1 by 2 minus cos of z is log x. So your answer is here minus x square upon 2 log of x into cos of log x. This is the particular integral of given differential equation. So here the topic Cauchy Euler equation is completed. So if you are having any queries related to that topic, then you can ask. Yes, students, any queries from your side? Yes? Any queries from your side?
हेलो मैम।
हाँ बोलो।
मैम जो अपन केस केस फाइंड करते हैं, केस 1 है, केस 2 है, केस 3 है, ये थोड़ा रिवाइज करा दीजिए कि मतलब कैसे मतलब आइडेंटिफाई करते हैं केस 1 है, केस 2 है। जैसे अभी वाले प्रॉब्लम में केस 2 था, तो यही थोड़ा रिवाइज कर दीजिए।
हाँ, सी फर्स्ट स्लाइड, 1 मिनट। हाँ, here these are the cases of finding particular integral. If your right hand side is e to the power ax, e to the power ax means e to the power 2x, e to the power 3x, e to the power 4x. So we have to apply first case, that is replace d by a. If your right hand side is e to the power a, e to the power ax, suppose right hand side is e to the power 2x. So we have to apply case number 1, replace d by a. A means 2. Yes. And the second case is when your right hand side is only sine ax, means suppose your right hand side is sine 2x, sine 3x, sine 4x. So you have to apply case number 2. So in that case, you have to replace d square by minus of a. A is 2 here. So d is replaced by minus of a square, means d square is replaced by minus of 2 square, and 2 square is 4. So this is equals to, answer is minus 4. So case number 2 is right hand side is sine ax or cos ax. Third case is when right hand side is x raised to power m. X raised to power m means suppose your right hand side is x square. Your right hand side is supposed to be x cube. Your right hand side is supposed to be x square. So in this case, we have to take lowest degree term from the denominator common and convert denominator in the form 1 plus x, and we have to shift this term in numerator, that will be 1 plus x inverse, and apply the binomial expansion. अब binomial expansion में बहुत सारी terms आएगी, तो हमको वहां से कौन सी term consider करना है? x का power देख के आपको d की terms consider करनी है. जैसे x का power 2 है तो d की term d और d square, x का power 3 है तो d square d cube, x का power 4 है तो d square d cube d to the power 4. According to this we have to consider the terms of binomial expansion and simplify this term, we get the answer. And the last case is when your right hand side is e to the power x into v, means e to the power 2x into sin x या फिर e to the power 3x into cos x, इस तरीके से आता है। तो ये रहेगा आपका केस नंबर 4। तो इस केस में आपको क्या करना है, आपका जो e टू दी पावर जो रहेगा उसको आप आउटसाइड में लेंगे और आपके d को रिप्लेस करेंगे d प्लस a से। a मतलब क्या रहेगा आपका, d प्लस a से। a मतलब कौन सी वैल्यू रहेगी, जो e का जो पावर रहेगा वो मतलब एक बार e टू द पावर ax बाहर आ गया तो रिमेनिंग टर्म इज ओनली cos x or x raised to power m. So according to case number 2 and case number 3, you have to apply the case and simplify this, you get the answer. Yes. Yes students, any queries?